Okay, first step, we've got to factor this. So I'm going to factor 3x out of both terms, because you always look for your greatest common factor before anything else. And if I take a 3x out of this, I get an x, and I have a -1. My denominator factors into x plus 4 times x minus 3. X-intercepts. To get my x-intercepts, I've got to set the numerator equal to 0. So 0 equals 3x times x minus 1. And once we've got this step, set each factor equal to 0. So 3x equals 0, x minus 1 equals 0, and solve. Dividing by 3, I get x equals 0, and I get x equals a +1. So my x-intercept is 0, 0, and 1, 0. We've got two x-intercepts. Next step is y-intercept. But remember, you can only have one y-intercept. And if I've already got 0, 0 as an x-intercept, it's also my y-intercept. So there's no need to solve for that. Okay, vertical asymptotes. We are going to take our factors and set each factor in the denominator equal to 0. So x plus 4 equals 0, x minus 3 equals 0. And we get vertical asymptotes at x equals a -4 and x equals a +3. So two vertical asymptotes, two x-intercepts. Okay. And horizontal asymptote are an oblique asymptote. We've got to compare the degrees. The degree in the numerator is squared. The degree in the denominator is squared. So that tells me it's a horizontal, so no obliques. And the equation of my horizontal asymptote I find by the ratio of the coefficients, the leading coefficients. So the coefficient in the numerator divided by the coefficient in the denominator. So y equals 3 is my horizontal asymptote. Okay, we've got to find or create our sign chart. We've got a vertical asymptote at -3, -4, and +3. We also have an x-intercept at 0 and at 1. It doesn't matter if this is not to scale at all. We just need to know what intervals we've got to check for signs. So I've got to check between -∞ and -4. So I would try -5. And when I plug in r of -5, I get something positive. And again, do this yourselves so that you know how to do these steps. I've got them already written out. If I plug in -2, because that's between -4 and 0, so r of -2, I got a negative. Between 0 and 5, I plugged in a 0.5 there and got something positive there. Between 1 and 3, why not plug in 2? And I got -1 as my answer, so that was negative. And if I plug in something larger than 3, again, you could pick anything larger than 3. I went ahead and just chose 4. When I plugged that in and evaluated it, I got 4.5, which is positive. Okay, now let's get this graphed. This time, mark off your graph in units of 2, because we need a little bit more space on this graph. So here we go. There we go. And first thing we've got to put on are the vertical asymptotes. We said we had a vertical asymptote at -4 and +3. So 1, 2, 3, 4. And +3. Okay. We have to put in our horizontal or oblique asymptote. In this case, we had a horizontal at y equals 3. So 1, 2, 3. And again, we're going to put it in as a dashed line. So this was y equals 3, a horizontal asymptote. X equals -4, it's vertical, and x equals 3. We also had a couple of x-intercepts, 0, 0, and 1, 0. So let's mark those, 0, 0, 1, 0. And now we've got to start graphing this. So we know as we get close to -∞, my function's got to be close to this. So it's either going to be right above or right below this asymptote. Well, my sign chart tells me it's positive, but both sides of this are positive. So that's not the most helpful yet. As we get close to the vertical asymptote, I'm going to have to curve. So I either curve up if I'm above the asymptote or down if I'm below it. If I was below this and curved, I would have to cross my x-axis. But I don't have an x-intercept here. So I cannot be on this side of the horizontal asymptote. I must be above it. And again, I can decide that because there is no x-intercept here that is smaller than -4. And let's do the other end. We also say that we're positive here. So by the same logic, I must be starting above and curling because I have no x-intercepts down here. If I was below that horizontal asymptote, as I came close, I would have to curve downwards. But I cannot cross the x-axis without having an x-intercept. Okay, what's going on now in the middle? So in the middle, between -4 and 0, we said we're negative. So I've got to be down here. I've got to come up to that x-intercept. Now I've got to see between 0 and 1, do I actually cross and come up to the positive, or do I bounce and go to negative? Well, between 0 and 1, we said it's positive, so I must cross over. Let's make that a smooth crossing. And at x equals 1 is another x-intercept, so I've got to come back, make my function curve down. And again, I've got to see, do I touch and bounce back, or do I cross? So I need to look at the sign between 1 and 3. I've got negative values, so I must be crossing again. And as we get close to the vertical asymptote, my y values must be going downwards. So this is what my function looks like. I've got a piece up here. Then I start down low, come up, cross at 0, cross again at 1, go down, and start up again with the very large y values, and then get close to y equals 3 as we go towards infinity. Okay, let's turn this over and look at example 5. Okay, here is example 4, actually, just so you can take a quick look at it if you want to pause the video. But the two things I wanted you to see is that this one had a hole because our factors canceled. So when I graphed it, after I did all that work, I saw that I've got to draw a hole here when x is positive 2. So I drew my curve and then just made a hole there. Okay, let's take a look at number 5 now. 5, we're trying to build a polynomial given a graph. So the first things we've got to do is, I see some vertical asymptotes. So let's go ahead and identify. We've got x equals -5, x equals a positive 2. So the factor that would be associated with this would be x plus 5 and x minus 2. Those would be my factors for the vertical asymptote. I also see that I've got some x-intercepts here. So x equals -2 and x equals a positive 5, that looks like. Again, the factors that would be associated with these x-intercepts, this would be x plus 2, and this one would be x minus 5. Now, one other thing to notice, the behavior. At x equals 5, we crossed, so the multiplicity of this must be something odd. And I'm going to assume it's the lowest possible, so a 1. The multiplicity when x is -2, we come up, we touch, and bounce back. So it's got to have an even multiplicity. So we'll call that a 2. So now let's put these pieces together that we have. My numerator, or where the x-intercepts come from. So I've got x plus 2 squared. I've got x minus 5. The denominator is where I get my vertical asymptote, so I'm going to put those factors down below. Okay, and the last thing I need to check is my horizontal asymptote. It's at y equals 2. Well, when it's anything other than, when it's a number other than 0, that means that I must have the same degree. My degree on the top right now is 3, x squared times x. But my denominator is x times x is only x squared. So I need to square one of these terms to get another x. It does not matter which one you square. Let's just square the x plus 5. And I need my leading coefficients to be 2 in the numerator and 1 in the denominator, so that 2 divided by 1 gives me the horizontal asymptote of